Hello, Rickoff here. Welcome to video number 14 of Rick's Pipe Dream Magnetic Motor Generator Project Series. Now before I get on a roll with another demonstration, I'd first like to point out how I have the bicycle wheel mounted to the frame. As you can see, there's a metal plate which is attached to the PVC frame members, and then the axle is mounted to the metal plate. Now this plate is actually called a code protection plate, and it's available at most hardware stores or at home building supply stores such as Home Depot or Lowe's. Code protection plate. And these plates are used inside walls of structures, and the purpose of these is to prevent someone from accidentally drilling or driving a nail through the wall into an electrical circuit or plumbing. So that's the purpose of these, but they make a nice mound and they're relatively inexpensive. Now you can see that the end of the axle is showing with a nut on it. It's not a very wide nut, and it's called a jam nut. Jam nuts are not quite as wide as standard nuts, and the reason I use jam nuts here is because it's the only way I could fit everything, quite simply. Now what you see is the end of the axle with a jam nut, and below that is a large washer. That's called a fender washer, in case you're wondering. This is a 5/16 inch axle. And this goes on the front wheel of a Huffy 26-inch steel chrome-plated bicycle wheel. Okay, now I would actually prefer to use the rear wheel, which has a 3/8 inch axle. It's more heavy-duty, and the bearings are also quite a bit more heavy-duty. The only thing that prevented me from doing that was the fact that the bicycle that I salvaged had an extremely rusty rear wheel, and the bearings weren't very good on that either. Okay, now I'd like to pan down just a little bit to show you what's on the other side of the plate. You can't really see what's on the other side, so I'm going to pan down to the bottom view, which shows you the inside view of the plate. And you see that there's nothing more than another fender washer and another jam nut. You see that binds the shaft to the plate. Now above that, let me go back up again. Above that, what we have here is two nuts. Let me get a flashlight on that so you can see it better there. Now you can see there's two nuts there. One is a jam nut, which is used here to adjust and maintain the bearing setting. And then above that is a larger nut, and that's the original nut on the end of the bicycle axle. And that's used to lock up the bearing adjusting nut. Okay. Now here's a close-up partial view of a rotor magnet group, and you can see the two magnets stacked together. Each one that you see here is two magnets stacked together, and the magnets, each magnet is 3/8 inch wide, 3/4 inch long, and 1/8 inch in thickness. So two together gives you 1/4 inch thickness. Now there's two reasons why I'm doing this as a stacked assembly. The first reason is because it's more powerful than a single 1/8 inch thickness magnet. It's twice as powerful. The second reason is because it's more economical to buy smaller magnets. In other words, it costs less to buy 2 of these magnets than it would to buy one 3/8 by 3/4 inch by 1/4 inch magnet. Okay? Now I'm going to zoom out so that we can see the entire machine for this demo. I want to go out too far. Now for today's demo, I'll be using a different magnet configuration from what I was using in the last video. The last video I had all north groups facing up. Now this time I'm going to use alternating groups of north, south, north, south. Now this is my preferred configuration, and I might just say it's the cat's meow of magnetic configurations. Now I'll be using the stator arm in the same position that I used it in the last video, but there's quite a difference here as to what's going on. Let me explain. In the previous video, you saw that I moved the stator so that the south of the stator was aligned to draw in the north magnet group, and then when I got near the back end of the group, I'd shift the stator arm over so that the north side of the stator magnet would repel the group, giving a little bit of acceleration boost and bringing us around to the second group. But in the previous video, I had to swing the stator arm back this way so that the south would be lined up for the north group that would be coming in, you see. So this is different because the first part is the same. I'm letting the south draw the magnet group in. I'm repelling with the north, but you can see here that the north is already aligned to bring the south-facing magnet group in. See, I don't have to move the stator, it's already aligned. And then I repel with south at the back end of the second group. Now at this point, the third rotor group is coming around, and that's a north-facing group, and it's perfectly aligned under the south side of the rotor, see, so I don't have to swing the rotor at this point. The third group simply gets drawn in. The north group gets drawn in by the south stator, and the north of the stator swings over to repel that, giving the next boost of acceleration. The north is perfectly aligned for the south of the last group, and then swung over to south to repel that south group, giving the next burst of acceleration. So at each incoming and outgoing point, you have acceleration, and the acceleration will continue to spin the wheel faster and faster as long as you can maintain the timing perfectly. Now I see that we're almost out of time, and there really isn't enough time left to give the wheel a good spin with this mode of operation. So I'm going to say goodbye at this point, and I'll prepare for the next video, which will show and demonstrate to you how this mode works to spin the wheel. Thanks for watching Rick's Magnetic Motor Generator series.